Hello friends, this is Ralph, and in today's video I'm explaining the VCO section of the Behringer 2600. This partly applies to the original ARP 2600 as well, but the functionality of the Behringer 2600 VCOs is one area where, in my personal opinion, the Behringer 2600 really excels over the ARP 2600. So stay tuned. Whoa, I can already hear people objecting to my statement that the Behringer VCOs are better than the ARP VCOs. But please note, I'm talking here about the functionality, not the sound. Moreover, I believe that I am entitled to such an opinion because I have been using the ARP 2600 for the past decades and I had plenty of time to compare it to the Behringer 2600. By the way, I have created a bunch of other videos comparing the Behringer 2600 to the ARP 2600. If you are interested in hearing some sound comparisons, then please check out the playlist with all these videos. I put the link to the playlist into the description box and also up here. And if you are a beginner with the Behringer 2600, then please make sure you check out my quick start tutorial. I promise you, you will get up and running with this synthesizer in no time. Again, I put the link to this video into the description box and also up here. And now, without further ado, let's start the VCO tutorial. For that, we move over to the Behringer 2600. Alright, now let's have a look at VCO number 1 here on the Behringer 2600. As I said before, in my personal opinion, the VCO section of the Behringer 2600 is one of those areas where the Behringer 2600 really excels over the original ARP 2600. Here on oscillator number 1 you have two waveforms, a sawtooth waveform and a pulse waveform. On the original ARP 2600 you have a square waveform, which does not let you adjust the pulse width. But here on the Behringer 2600 you have a pulse waveform, and when you set here the slider to 50%, you get a square waveform. Alright, I want to show you how you route oscillator number 1 through the Behringer 2600 that you get a signal. So you bring up VCO number 1 here in the filter mixer all the way up, and the pre-wired connection is a square wave. Then on the VCA you make sure that the VCF is all the way up, and then also you bring in the envelope, the AR envelope, and then in the final mixer here you bring in the VCA. Alright, now we are going to listen to this sound. And this is oscillator number 1 playing a square wave. I have connected an Arturia key step to the Behringer 2600 via 5-pin MIDI. As I said, the pre-wire connection for VCO number 1 is a square wave. If you want to hear the sawtooth waveform of oscillator number 1, you have to patch this. You take the sawtooth output and plug it here into the VCF section. Let's take the ring modulator input. So this now is the sawtooth playing, and this is the square wave playing. And now both waveforms are playing at the same time. So, but also you can override the pre-wire connection by just plugging the sawtooth waveform here into the VCO number 1 square wave slot. This is sawtooth. This is square wave. Sawtooth. Alright, now let's have a look at the controls of oscillator number 1. Let us start with the initial frequency. Here you can adjust the pitch of the oscillator in a wide range. And then here you have a fine tune. And as I said before, here you can adjust the pulse width of the square wave. Since the pre-wire connection is a square wave, we can hear the adjustment. Please note that it doesn't go all the way down to 0 or to 100, otherwise the sound would be cancelled out. And now let's have a look at these controls here. The first switch is the keyboard on off switch. So with this switch you can change between the audio range and the LFO mode. If this switch is up, keyboard on, then the keyboard is controlling the pitch of the oscillators. So now it's in low frequency mode. You almost don't hear anything. I just have to bring up the frequency all the way up. To hear something. But if you turn it down here to LFO mode, the keyboard has no control over the pitch of the oscillator. So you use this in the low frequency mode, usually for modulation purposes. So let's switch it back to keyboard control, audio range. And tune the oscillator back to an A. I usually like to tune by ear. I get a 440 Hertz A sound, and now I have oscillator number 2 also tuned to that, and I just used oscillator number 2 as a reference to tune oscillator number 1 again. So let us continue by looking at the other FM controls. Here you have a pre-wired sample and hold connection. So if I bring up this slider, let me play a key. The sample and hold is controlling the modulation, frequency control modulation of oscillator number 1. So let me bring up the rate of the sample and hold, and also here on the noise generator, the level. So now you hear the typical sample and hold sound. If you don't know what the sample and hold module is doing, then please check out my tutorial which explains the sample and hold module in detail. So the next slider here is the ADSR FM control, the pre-wire connection. This lets us control the VCO pitch with the envelope. And the final pre-wire connection here on VCO number 1 is the LFO. The LFO section is here, and the pre-wire connection into oscillator number 1 is LFO. The triangular waveform. So you can create subtle vibrato sounds by using the LFO into the pre-wire connection of VCO number 1. And finally, I want to talk about this slot here, the keyboard CV slot. As you see, there is no slider controlling the amount of the keyboard CV. That means when you connect a keyboard to the Behringer 2600 via MIDI, and this slider here is set upward into audio range, keyboard on, then the connected keyboard is controlling the pitch of the Behringer 2600 oscillators. So why do you have this slot here anyway? There might be a reason that you want to connect a keyboard like the Arturia KeyStep via CV gate. I have made a tutorial about this procedure. I put the link to that tutorial also into the description box of this video. If you want to learn about this, please check it out. But here back to the keyboard CV. You need this slot if you want to connect another keyboard via CV gate to the Behringer 2600, or for instance a digital or analog sequencer to the Behringer 2600 via CV gate. And also, if you wish to combine the Behringer 2600 with other modulars, synthesizers and modules, Eurorack modules, then you may need this slot here. But this is a more advanced subject. Let's move on to oscillator number 2. Okay, now let's have a closer look at VCO number 2 here on the Behringer 2600. The first 3 sliders are exactly the same as on oscillator number 1. The first difference between these oscillators is here the sync on-off switch. I will talk about this later. The same sync on-off switch is also available on oscillator number 3. The next difference between oscillator number 1 and 2 is that here on oscillator number 2 you have 2 more waveforms, the triangle waveform and the sine waveform. The pre-wire connection of oscillator number 2 going into the filter is a square waveform, yet again as on oscillator number 1. So now let's listen to the triangle waveform. So we take a patch cable, plugging it here into the triangle output, and plug it here into the VCO number 2 square waveform slot, overriding the pre-wired connection. So now we are listening to the triangle waveform. When we unplug it, you'll listen to the square waveform again, which is the pre-wire connection. The triangle waveform. And now let's change to the sine waveform. Okay, we can listen to the triangle waveform and the sine waveform at the same time. So we take another cable, taking the triangle output and run it here in the filter mixer. Let's take the ring modulator slot, and then we bring up the slider. Now we are listening to both waveforms, triangle and sine. This is sine, this is triangle, and these are both waveforms playing at the same time. They are perfectly in tune because both waveforms originate from the same oscillator, that is oscillator number 2. So now let's take out the patch cables and we move on to the FM control section here on oscillator number 2. The keyboard CV slot is exactly the same as on oscillator number 1. Also, the sample and hold control is also the same as on oscillator number 1. And the same applies also here to the envelope ADSR control, which is also the same as on oscillator number 1. And now we move to this slot here, VCO number 1. This slider is a little bit different because you have the option to choose between the low frequency mode and the audio range mode. So let's change the oscillator number 1 to low frequency. We press a key, and then we bring up the slider. So you can hear, as I change the pulse width of oscillator number 1, which is running in low frequency mode, how this impacts the modulation of oscillator number 2. All right. Let's change oscillator number 1 back into audio range. We move this slider upward. And now oscillator number 1 is running in audio mode again, controlled by the keyboard. And now I play a key, and I bring in here oscillator 1. So what is happening here is now FM synthesis, exponential FM synthesis. As I increase the modulation depth, the pitch changes compared to linear or through 0 FM synthesis, where the pitch stays the same. If you want to learn a little bit more about this subject, FM synthesis, please Google it and read up on it on the internet. So this here now is exponential FM synthesis. And also remember, since oscillator number 1 is in audio range, which is controlled by the keyboard, the pitch of this oscillator number 1 is controlled by the keyboard. Also, this changing pitch is modulating the frequency of oscillator number 2. Okay, you can also bring in some reverb. Okay, you get some really weird sounds from this. Okay, so let's move this slider down again, and then we come to the last slot, pulse width modulation. The pre-wire connection is using the noise generator to modulate the pulse width. We can change the tonal character by changing from low frequency to pink noise to white noise, and also changing the level of the noise a little bit. Okay, this is a rather dirty sound, but in order to get this classic pulse width modulation sound, we should use either a triangle waveform or a sine waveform. So let's take the sine waveform from the LFO and we plug it here into the pulse width modulation slot. And now the LFO is modulating the pulse width of oscillator number 2. So by doing so, you get this classic pulse width modulation sound. Bringing in some reverb. Totally up to you. Alright, now let's take a look at oscillator number 3. It's pretty much identical to oscillator number 2 We have the same sync on-off switch here, about which I will be talking in a moment. We have the same waveforms, and then the pre-wire connection going into the filter is a sawtooth waveform. So let's move now to the FM control section. Yet again, we have the keyboard CV slot, and then we have a pre-wire connection, the noise generator, modulating the frequency of VCO number 3. I move up this slider, change the level on the noise generator, low frequency mode, pink noise, white noise. I add some reverb. Okay, now let's move here to ADSR. It's the same as on oscillator number 2. Okay, and then here we have a pre-wired connection VCO-2, a sine waveform, modulating the frequency of oscillator number 3. So for that, let's switch oscillator number 2 into low frequency mode. And now we can create this classic vibrato effect. Okay, the same can be achieved here with the dedicated LFO. It also has a sine wave output. Now, let's switch oscillator number 2 back into audio mode. And now the pitch of oscillator number 2 is controlled by the keyboard again. And then we crank up the slider. So we have the same FM synthesis taking place, which I explained when I was going through oscillator number 2. But yet again, I want to stress, please bear in mind that when it is in audio mode, any oscillator, so in our case here, the pitch of the modulating oscillator is changing, and also the pitch of the oscillator number 3, which is modulated by VCO-2. Okay, and now here we have the ADSR modulating the pulse width. When I move up the slider, nothing is happening. That's a little bit contradictory, because the pre-wire connection going into the filter is a sawtooth waveform. So in order to hear now the effect, the ADSR modulating the pulse width, we have to take the pulse output and plug it here into VCO-3 slot, overriding the sawtooth connection. And now we can hear the ADSR modulating the pulse width. If I move the slider all the way up, you hear that the sound is being cancelled out. That's due to the fact that the modulation goes beyond the 100% pulse width. And if you invert it with the voltage processor, it's going below the 0%. And that's the reason why the sound is being cancelled out. So just move the slider a little bit down. And then you get the modulation effect. If you want to learn about the voltage processor, please check out Another tutorial from me which explains the voltage processor in detail. I put the link into the description box. If you want to learn about it, check it out. So that's pretty much here oscillator number 3. Now let's hear all 3 oscillators playing together. I use the pre-wired connection of VCO-1, crank it up, and then also VCO-2, crank it up. So you hear I slightly detuned oscillator number 1 and 2 to get some kind of chorus effect. Okay, and oscillator number 3, I tuned it to a quint. So you can create some pretty cool chords with all 3 oscillators. How you tune them is totally up to you. And now let us talk about the sync on-off switch, which is available on oscillator number 2 and 3. So now I have VCO-1 and 2 in the filter mixer. And you can hear that they are slightly detuned. Now I switch sync on oscillator number 2. That means they sound perfectly in tune now, which is actually due to the fact that oscillator number 2, the pitch of oscillator number 2 is locked to the pitch of oscillator number 1. And when I start changing the frequency of oscillator number 2, I can create interesting harmonic effects. But you don't want to do this manually all the time while you play the keyboard. You can use, for instance, the pre-wired ADSR modulator. To create that interesting biting sound. Now let's add VCO number 3 doing the same thing. I take out VCO number 2 and now I slide in VCO number 3. You hear they are slightly detuned at the moment, VCO number 1 and 3. And now I switch sync on oscillator number 3. And now VCO3 is locked to the pitch of oscillator number 1. Okay, but this time we are not using the ADSR to modulate the frequency of the synced oscillator number 3. We use the LFO, the sine wave. So we take the LFO sine wave output and plug it here into the noise generator slot in the FM control section of oscillator number 3. You hear it now? The LFO now is creating the effect. And we can also bring in oscillator number 2, which has the ADSR controlling the effect. Okay, now I can also bring in the ADSR for the filter. Okay, This you can do with a sync feature. You can create some really cool biting, distorted sounds. And now I want to tell you why I personally believe that the VCO section of the Behringer 2600 excels over the VCO section of the original ARP 2600. So on oscillator number 1, you have here on the Behringer a sawtooth and the pulse output. Whereas on the original ARP 2600, you have a sawtooth and a square wave output. You cannot change on the original ARP 2600 the pulse width. So then now let us move over to VCO number 2. VCO number 2 on the ARP 2600 has all the same waveforms and also the option to modulate the pulse width. So this is actually pretty much the same like the Behringer VCO-2, but on the Behringer 2600 you also have the sync option. You can sync oscillator number 2 to the pitch of oscillator number 1. So now let's move to oscillator number 3. Oscillator number 3 on the ARP 2600 has a sawtooth waveform and a pulse waveform, but there is no option to modulate the pulse width. You have to do it manually, whereas here on the Behringer 2600 you have the pulse output and also the option to modulate the pulse width, be it an ADSR, be it an LFO, be it the noise generator, whatever you wish. It's totally up to you. And then on top of that, you can also sync oscillator number 3 on the Behringer 2600 to oscillator number 1. So this is why I personally think that the Behringer 2600 VCO section excels over the VCO section of the original ARP 2600. But that's just my personal opinion. Alright, what do you think about the VCO section of the Behringer 2600? How does it compare to the ARP 2600 VCO section? Please share your opinion with the community here. Kindly write a comment. I also wish to thank everybody who has commented on my previous tutorials. Some comments contain some really cool patch ideas, so thank you very much for that. Alright, and before I sign off, let me tell you, if you are interested in the Behringer 2600 and the ARP 2600, then you have come to the right place. Please make sure you subscribe to my YouTube channel, and when you are there, kindly also check out some of my synthesizer music, ranging from IDM to ambient house to Berlin School of Electronic Music. And when you are in a cozy subscribing mood, then please also follow me on Instagram and Twitter. I put the link to my other social media accounts into the description box. I hope I see you there as well. Okay, I wrap it up here. Thank you so much for watching. I hope to see you again in my next video. Until then, take care, stay safe, peace!